All right. Submitted the first WMS homework assignment. I got some questions before class about like what level of detail do you need to show in the screenshots that you're submitting. And for this first assignment, it's probably not too critical that you break it up into lots of steps, although I do prefer it if you kind of think about the workflow and take a screenshot at the end of each process. You know, for instance, once you've identified the project area, you could take a screenshot there. Once you've loaded in the DEM and done topaz, you know, that could be another screenshot. So kind of think about it in terms of steps. And the advantage of submitting it that way is that, you know, later on you're going to stop using WMS and you're not even going to think about it for months, but then a couple of years down the road you might find yourself in a position where you've been assigned to some new project and WMS maybe could be a useful tool, and you're not going to remember how exactly you did things. And so having that assignment where you kind of showed yourself what the process was would be useful. So the first assignment that you just submitted, if you only gave me one screenshot, maybe that'll be okay. But for the next assignment, for this WMS number 2, it's more important that you really illustrate multiple steps along the way. And so take a couple of screenshots to show the process, because at the end, there's just going to be a lot going on all at once, and it would be tough to represent the entire thing in a single screenshot. All right, so that assignment's going to be due on Tuesday the 27th. And actually, I think you maybe already know most of what you need to do for that WMS number 2 assignment. I think it goes through using NSS and TR55. So to begin today, we're going to reiterate the TR55 with a watershed in Morgantown, and then we're going to also run the HEC-1 model on that same area. And it'll be kind of interesting to compare the different flow rate values that we get for TR55 versus HEC-1. So in the handout I'm giving you right now, I identify where the outlet of the watershed is. It's at the intersection of, I don't know, is that it's not the Ohio River that goes through Morgantown, is it? What's the big river that goes through? Is it the Monongalia? All right. So it is where on the north side of town we've got a pretty good sized watershed concentrating, and you can kind of see on the map that I've given you and where the arrow is that there's a depression where that stream is going in. But I'm not going to show you exactly what the full extents of the watershed are. I'd like you to get the practice of kind of figuring that out. I'll be working through it on the screen, so if you want to glance up and see if you're on the right track, we'll be doing the same thing together. So the first thing is just delineate the watershed, and to do that you're going to have to download the DEM. But then work towards doing TR55. So on the handout it says to get the NLCD and the Sergo. We'll do that later. You don't necessarily need to do that first thing. definitely matters. Probably that. Yeah.
So it's recommending that just...
Yeah. I mean, it'll usually, if you go one step finer than it recommends, then that's conservative. You know, you better to be safe than sorry. It'll take a little bit longer. Yeah. If you look at your coordinates, something's off there. So what I do is start over and begin a new project. Well, first go in here and see if you can define bounds. Change it to, for the datum, do the bottom one, and then change projection. Like kind of setting it again would maybe, if it's not quite sure on what the projection is, overwrite what it was doing before. So choose from the library. UTM zone 17, okay, and accept that. Okay. And then now you can define the bounds. I think maybe it wasn't seeing the bounds, so you can, okay, yeah. Click there and back again. All right, now you can go next. Yeah, that's good. Mm-hmm. How many? So somebody asked the question, you know, like what DEM resolution should you use? And usually it's going to suggest something that will allow it to calculate topaz pretty quickly and do the delineation pretty quickly. And so usually, like, I think about how much time am I willing to invest. I'm usually willing to go a little bit beyond what it suggests. And so if it suggests 60, I go with 30. If it suggests 30, I'll go with 15. But, you know, there really is no right or wrong answer. It's just kind of a trade-off between how long are you willing to spend to download the data. Does your computer have the RAM to keep it all in the memory? You know, I probably could have done this at the 3-meter resolution and it would end up working just fine. But, you know, if it becomes too coarse and you see really jagged edges, like if you look at the blockiness of the outside perimeter, sometimes that can give you an idea of whether things are okay or not. You know, like if it is, if you know that there's a little bit more detail in the shape of the hill than the blockiness of the DEM is able to capture, then you might want to step down a level and improve the resolution. So once you get the DEM in there, you can trim it to throw out the stuff that we don't need outside the watershed. And maybe save your work in case it crashes later. All right, so once everybody gets the watershed, then we're going to load in the land use and the soil type data. So I'm going to wait until then to show you how that'll change things. What we're going to do now is we're going to load in the National Land Cover Database, and Surgo. And so if you go back into the wizard and download data, so we already have the elevation data, so unclick that because we don't want to download that again. But do check NLCD, that's the National Land Cover Database, and we've looked at that before. We pulled it up on Google Earth Pro, where we were just loading in what areas are impervious, what areas are deciduous forests, what's cropland, and so on. That's the type of data that's in the Land Cover Database. Then also scroll down, and we want the soil data. That's the Surgo soil data. Now, for whatever reason, WMS in the past hasn't been real good at picking out the right Surgo soil data, and it'll actually get way more than we actually need. So after we download this data, it might start displaying it at a view that is really zoomed out. So our project view is going to change probably. Excuse me. So just once you have those two things clicked, then select Download Data from Web, and just use whatever default assumption it wants to give you for the raster size. That is, it's trying to suggest a size for each cell in the land cover database. So just use the default. You can see it's downloading the soil data. It'll get the land cover data, and then over here on the left side, now it's changed the project view. So we're looking at two separate things. First of all, I'm going to switch off the street map. So these black polygons are the soil data, and I can switch it off down here. So you can see that since my view covered two different regions, it downloaded both of those regions' soil data. So it may be that my watershed it looks like the entirety of my watershed is just in the 611. It downloaded the 77 because part of my view extents went into the 77, but I don't need the 77. I only need the one that's covering my watershed boundary. So here's my watershed boundary, and when I click on the 611, the soil data from 611 covers the entire boundary that I need. So I'm just going to right-click on the 77 and delete it from the project because I don't need it at all. I can turn on the 611 again, and it's there. By the way, this is a good time to save your work again. So if you just click on the Save button, then all of these things that we're working with are saved in the same project directory. The TIFF file, that is the image that's in the background, and you can see it's created an image version of this land cover database. So that's what this TIFF is it's the colors that we've seen before. But also, here it's loaded it as a land use into the grid. So it's not showing up, but that data is there in its memory. So what it's actually going to look at to try and figure out what land is in what location is this land use grid. So if I turn that on, then you can see this is kind of, each of the colors represents a different type of land use, but the image version of it is also loaded in the GIS data. So what do you think red means in this view, the GIS data TIFF file? Buildings, yeah, built up areas, right, good. Blue is water, green is plants, and different shades of green mean different types of plants. If you go to MU Online, there's a folder here called WMS items, and you need to download something that's called the CN table file. So if you just click on it, it's just going to display the text, but what you want to do is right-click on it and do Save Target As, and then browse to a location that you're going to be able to find. Here I'm putting it in my WMS Day 3. So that curve number table, you can open it with the notepad if you just want to look at what's in there and if you wanted to edit it. You need to display all files because it's not formatted as .txt. but the curve number table, all it really is a text file. And so what it's showing is these numbers on the left side. So number 11 is what open water comes up as in the National Land Cover Database. 11 is open water. And so then these four numbers that follow is the curve number associated with open water for type A soil, type B soil, C, and D. So water doesn't make much sense. But then if you look at something like deciduous forest, so color code 41 in that National Land Cover Database, if it's in soil type A, it's going to assume a curve number of 30. Soil type B, it's going to use a curve number of 55, and so on. So later on, we're going to load this file in as kind of like a key so that Excel knows those polygons of soil type overlaid on top of the raster file that's the land cover, what curve number should it assume for each one of those intersections. So download that so you've got it available. All right, so what we've got is the land use, and we've got the soil type, and we're going to use it to calculate curve numbers. Everybody have it so far? All right. Yeah, you mean like, can we trim the soil? Mm-hmm. Yeah, we'll do that. Although this doesn't take up too much data, not as much as you might expect, because each one of these polygons is a vector rather than a raster. So vector files usually are more compact for a certain area than an image file would be. All right, so let's start with the soil type. We've got some instructions here under the bulleted list. Let's just go through them one at a time. So we've deleted the one that we didn't need. All right. The first step that we have to do once you've deleted that other shape file that wasn't supposed to be there, right-click on the 611 file, and one of the options here is Join NRCS Data. Does everybody see that? If you right-click on the soil 611, then one of the context-specific options is Join NRCS Data. So what that's doing is right now it doesn't know for each one of these locations, it doesn't know what soil type it is. Like we can select the properties, and what it's popping up is if you just click one of these polygons, it's telling us what area it's in. So it's in West Virginia, soil file 611. And it has this soil key. And you remember seeing those three-letter abbreviations when you did the assignment having to do with like an area of interest. So it knows that soil key information, but it's not automatically pulling up the hydrologic soil group. Hydrologic soil group is that A through D classification. So right now we can click on these and we can know inside our watershed what each one of the soil types is, but it doesn't have hydrologic soil group yet. So that when you click Join NRCS Data, then it's going to go in and match up each of the soil types to its corresponding hydrologic soil group. Now there may occasionally be some area that it doesn't have the hydrologic soil group for. And so fill blank values is a way of saying, well, if there's any place that we don't have the data for, then you can just assume that it's soil type, whatever. And so if you want to be conservative, like any location that you don't have a hydrologic soil group assignment for, if you assume that it's D, then that would kind of give you the worst case scenario for runoff. But even if we don't have it fill the blank values, I think in this area, all of the polygons have the data that it needs. But we'll do a curve number report, and we'll see if there are any areas that don't have values. And then if we have some that were empty, then we can fill the blank values using that. So again, all we did was we right-clicked, join our NRCS data, and then just click OK. And what we're doing across the top here, join hide group, that's the important thing. It's going into one of these other files. If I go into the directory where all of this data has been downloaded, you'll see that there is a Morgantown Surgo file, and there's lots of different data files where the 611 is the one that we are working with. That might be in here. Yeah, so here's the WV611, and the hydrologic soil group is one of these text files that it's going to have to join up to get the correct soil type. So click OK, and now if we do the identify tool again and you pick some polygon in your watershed, you can see now it has a lot more characteristics than it did before. Now not only does it have the 3-letter abbreviation, but it also has some soil properties like the moisture content, field capacity, wilting capacity, but most important to us is the hydrologic soil group. So, there's some that's A, here's one that's C, here's one that's C. So all of these little polygons inside our watershed now has a soil associated with it. So is everybody able to join that soil data? Assignment with them. So when we calculate the curve number, we'll see how much of the area doesn't have a hydrologic soil group assigned. So to compute the curve number, now we're following the steps on the back side of the paper there. We want to, there's a couple of ways to do it. You can create a new coverage. You can see that right now we have a drainage coverage. Well, you can also copy over all of the soil data into a new coverage, or you can compute it straight from the soil type file. Let's, just to save time, try doing it straight from the soil type file. It may crash because we've got a pretty big area, but it saves you from having to trim, which can take a while. So move over to the, let's see, hydrologic modeling module. So here at the top, the hydrologic modeling module, and then under calculators, so that menu option across the top, calculators, what we're going to do is compute GIS attributes. And so we want to calculate curve number, and we're going to use GIS layers. Nope. All right, cancel. We are going to, it used to be a little bit different. All right, we're going to create a new soil type coverage. So starting at the top, right-click on coverages. So the word over here under map data, you see coverages. Right-click coverage and click new coverage. And under the coverage type, instead of general, change it to say soil type. So we're going to create a new soil type coverage. And click OK. And so now you'll see that under coverage, now there's a drainage coverage, which is the boundary of our watershed, and then make active the soil type coverage. And what we have to do now is copy over the data into that soil type coverage that we want to keep. So right-click on the soil type and okay, select shapes. They've moved the buttons around. All right, so here's what we do. Under GIS data, select the shape file that has our soil data, and then using the Select Shapes tool, which is underneath the Identify tool, highlight all of the area that encompasses the entirety of your watershed. So once you've selected it, then go up here to the Mapping menu. So does everybody have it highlighted in blue? Okay, once it's highlighted in blue, then you go to this Mapping menu and you do Shapes to Feature Objects. So what this means is it's going to take all of the data from this 611 shape file and copy it into the soil type coverage. And it's only going to do the part that we've got highlighted. So it's just the soil type polygons that are related to our watershed. And a lot of the ones, like if we zoomed out, a lot of the area that isn't covered in our watershed, it's not going to copy over those polygons. All right, so have it say that it's going to go to the soil type coverage, and here's the shape file. All right, so click Next. And what we want to make sure that it knows is that what it has in the table as a hydrologic soil group, it's going to copy all of that data as SCS soil type into the new soil type coverage that it's creating. So click Next and Finish. And so now it's copied all of that over. We can turn off the 611 shape file. And now that the soil type is colored and active, you can see that it covers the watershed area. If we go back to our drainage module, then it'll take the soil type stuff black and white, and we have all of the polygons covering our area. So now we can calculate the curve number because it has land use, which is that National Land Cover Database. It's got the soil type, and so now go into the hydrologic modeling module and calculators and compute GIS attributes. Now, hopefully, it's going to use our soil type coverage for determining soil type. It's going to use the grid data, which is the land use grid, for determining land use. And then the other thing that we have to do is, you can see it has a summary of the table it's going to use to translate all of that into curve numbers. We have to import the .tbl file that you downloaded from MU Online. So click on Import and change it to all files, and it's so the IWW curve number file. And now you can see that it's read in all of the curve number assignments that we want for different land use types. So when we click OK, what it should do is go through a process of calculating the composite curve number, and then it's going to output those calculations into just a text file that it's going to open up with, in this case, since I have it on this computer, the notepad. And so it tells me how much area there is that was developed medium intensity land use with a soil type C, and so then it tells me what curve number it assigned for that area, and then the product of curve number times area. This column is because it's going to determine a weighted average with those details. So at the bottom it says that my watershed has a curve number of 69.6. I see some nodding and some shaking. Let's pause for a moment. All right, so it calculated the curve number, and it copied that curve number into whatever model is initialized over here. So right now it says HEC-1. Let's switch it over to TR55. And if we open up the dialog box for TR55 by double-clicking in the basin, then hopefully what we'll see is that curve number of 69.58 has been copied in to the runoff curve number area. And it knows the drainage area, so 8.88 miles approximately. We can calculate the time of concentration, so if we go into the basin data and we switch down to the SCS method, it automatically knows the length, the curve number, the watershed slope, and so it's going to calculate and fill in the time of concentration. So in my case, 3.2 hours. The only thing that we'd have to do is change it over to a type 2 distribution, and then we need to find out what is the 24-hour storm for what we want to analyze. So if we want to know, for example, the discharge for a 5-year storm, then we'd go over here to the precipitation frequency data server and find out from Morgantown what is the storm depth for a 5-year storm. Okay, so I've got the crosshairs on Morgantown. Go down here, find the 5-year storm, 24-hour depth, 3.06 inches. And so if I switch here now to 3.06, as soon as I move away from that, it's saying, all right, that the peak discharge is going to be 860 CFS. And let's write that down because we're going to compare the TR55 estimate. TR55 estimated that it is 860 CFS for the 5-year storm. Okay? And we can compute the hydrograph and see what that looks like. It's going to determine the hydrograph based on the 24-hour storm event, where that typical shape of the precipitation, like when the storm is happening, is that there's very little rainfall at first, and then there's a big upswing and most of the rainfall occurring at a certain time.
That line that connects to that dot where you pull up the TR55 data, that line is not probably double line. And I've hit the dots up top.
No, I'm going to fluid mechanics right now. So I think...
Do you have time tomorrow?
Yeah, I'll be in tomorrow.